Welcome, Math for Teachers 2 students. This is a review of Lesson 23. We're looking at Proportional Reasoning, Part 1. I'll ask you to pause, make sure you read through this goals slide, and pay attention to the language and specific math vocabulary. Take time to read and maybe make a few notes. If you're creating that math vocabulary dictionary or list, this is a good time to add to that as well. Continuing with the goals, there's 2 more to read over, and there's one key term for lesson 23, and that's ratio. So ratio is a multiplicative relationship or a comparison between 2 quantities. Ratios include, in this example, that there are 3 triangles and 2 squares. We can write that in various ways. 3:2, or 3:2, or 3/2. And we're going to learn the language, the appropriate language to be using with our children. Again, I would ask you to hit pause, make sure you're reading how to prepare and what we'll do in this video. The resources, those are the last batch of information when you go into the submodule for each of the lessons. But let's take a look at this website. It's called Bite Sizes, and it's an interactive website. Okay, Bite Size is a website from the BBC, which is in Britain or the UK. And again, when you're using any website, you want to make sure that everything is available to you. In this one, we're going to look at what is a ratio, and we see the monsters. So we're going to hit play, and you're going to find that this content is not available in the United States. So really exciting, right? Dinosaurs, monsters, whatever these are, right out to show you 2:3. Again, we'll learn that language, but it's not available. So it's good to pop open websites, review them, rehearse how you're going to use them, and then have them at the ready. So for this one, we should have been sliding down. This website gives definitions, so this is a slightly different one. It's saying that a ratio shows how much of one thing there is compared to another. Ratios are usually written in the form of A:B. Right? So let's go down, and it continues. So it is a scaffolded website as well, where it goes from what is a ratio to simplifying ratio. So I'm going to click on this interactive pointy finger. Let's see what happens. Okay, so drag 5 dinosaurs to show the ratio of 2:3. So 5 dinosaurs. 1, 2. Remember to have your children join in with your counting. 1, 2. Now let's stop and let's check and let's see. This is another thing to look at when you're using technology, because remember, we're trying to keep our vocabulary positive with our young children.
That's not right. The first number is for the blue dinosaurs and the second is for the red ones.
Okay, so then it gives, again, scaffolded information. The first is for blue, the first number, 2, is for blue, and the second is for red. Okay, so we're going to hit retry, which is great. That's a positive for any website, that it doesn't just go wrong. So 2 blues, 2, and 3 reds. 1, 2, 3. Right? And now let's check it.
Awesome! That's right. There are 2 blue dinosaurs for every 3 red. That makes a purple dinosaur.
Right, so they've taken even one step further and said, if we mix blue and red, it makes purple, which not really terribly relevant to what we're doing, but away we go. Now we can retry that, or let's see if we click this arrow, what happens. Just going back and forth. That's kind of misleading because it makes you think there's going to be another problem. Okay, let's head back. Okay, so this slide is showing us the meaning of the fraction symbol. Until this point in the semester, we focused on two specific meanings of a fraction numeral or symbol. So 2/3 plus 12 equals, and 2/3 divided by 12 equals. These both mean 2/3 of a BMU, a basic measuring unit, which is a measurement. But if we come over and we look at 2/3 times 12, this does not mean 2/3 of a BMU. This symbol tells us what to do to the 12 as an operator. So we're going to begin today, today we will begin a unit where we view the fraction symbol in a third way, and that is as a ratio. So let's read the story problem together. For every 5 boys in Mr. Holland's classroom, there are 15 girls. A ratio, again, is a multiplicative comparison between two amounts. Consider the situation above. I'm going to hit pause here and say, consider the situation. I don't know if I would call a classroom of 5 boys and 15 girls a situation. So consider the story problem above. But again, this is a good example of, are you comfortable with the language that are in the slides provided to you as a first-year teacher? What is a multiplicative relationship between boys and girls? So we can write ratios in 3 ways. We can use a fraction symbol, right? 5 boys, fraction symbol is that line, and 15 girls. So the division line reads as for every. Okay, so does the colon. Oops, I jumped ahead. Using words, there's 5 boys for every 15 girls. That's using words. Using a colon, 5 boys for every 15 girls. So be thinking about this. We've talked about a lot of, again, vocabulary, different ways to state it. In this way, there are 3 different ways that we can write ratios: fraction symbol, words, or using a colon. A ratio can be stated as a part-to-part comparison or as a whole part comparison. 5 boys for every, using that division symbol, for every 15 girls is a part-to-part. Whereas if we say 5 boys for every 20 children, that's a part-to-whole. 1/4 of the children are boys. Again, we're looking at the word children is part-to-whole. And 3 girls for every 1 boy goes back to part-to-part. Okay. Again, I want to just remind you that if it's helpful when you're looking at slides, work pages, you can always cover it up, right? So index card, if you're doing overhead projection, you could do a box like I did, and then remember you can slide it over. Or in this case, we would read this one. This is actually what I would do, right? I would do 2 boxes. Okay, so 5 boys for every 15 girls. Which is that? Is it part to part or is it part to whole? If I was doing with a group of students, then I could pull this down and reveal it. Okay, you can do the same thing visually as you're going through slides or also in your workbook. Okay, let's move forward. For every 5 boys in Mr. Holland's classroom, there are 15 girls. Many problems in the world are solved with ratios, assuming that ratios remain the same or are equivalent. Actually, equivalent ratios are probably the most used idea: money, pricing, projecting, when we're solving problems. So keep the context above. How many girls would there be if there were 10 boys in Mr. Holland's class? Okay, so we've now doubled from 5 to 10. If there were originally for every 5, 15 girls, if we've doubled our 5 to 10, 5 times 2 is 10, then 15 times 2 is 30. Okay, here's what that looks like. Again, would you, if you were teaching this, would you have 10 and 30 and kind of give that answer away, or would you have covered that up? So we see that for both ratios, the number of girls is always 3 times the number of boys. So if we have 5 boys for every 15 girls, and then we change it to 10 boys, how many girls? We're timesing by 3. So 10 boys for every 30 girls. And let's just hope that your classrooms never get to the size of 40. That's a lot of children in a classroom. Okay, last slide for lesson 23, and it talks about proportions. So the equation above is called a proportion. A proportion is an equation that states that 2 ratios are equivalent. Proportional reasoning problems include equivalent ratios where typically 3 out of the 4 quantities are given and the 4th is unknown. Children are asked to find that unknown quantity. Most of us have probably learned and are comfortable with cross multiplication algorithms for solving proportional reasoning problems like this, but there are lots of different strategies. And we're going to look at those together in lesson 24. This concludes lesson 23. The beauty of a video is you can go back and you can repeat and recycle whatever information you need. And if you have questions, please get in touch with your instructor.